to Mr. Bruce Bassett for introductions. Enjoy the class.
Well, hey there, good morning. My name is Bruce Bassett. I'm on the curriculum subcommittee for science, medicine, and technology. But more importantly, we have with us this morning our own HASP member Gary Morris as our presenter. He has a BA in economics from Michigan State University, an MS in artificial intelligence, and a PhD in machine learning from the University of Pennsylvania. He is an accomplished veteran presenter, so I know you're in good hands. This presentation is in several components, so there'll be a couple of slides for questions. If a question occurs to you and you don't want to forget, just type it in chat and I will keep track of it so that you can follow along the rest of the presentation without worry. On that note, I will turn it over to Gary. Here you go.
Thank you, Bruce. Welcome, everyone. We're going to be talking about the history of computing this morning, but I need to give you a couple of caveats. As soon as I can get my slides to behave here. All right. Well, it was working just fine before we started, and now I can't get my slides to advance. Let's see.
Sometimes, Gary, put your cursor onto the screen. Sometimes you, yep, okay.
There we go.
And now you should be able to advance in the regular way. Yep. Okay.
Okay. So caveat number one, this is not going to be a comprehensive history of computing. Obviously, that would take much more time than we have. I would like to characterize this as basically war stories from the front, or as Paul Harvey would have said, now you know the rest of the story. Some of the stories I'm going to tell this morning are about key moments in the history of computing, but some of them are simply fun but trivial details that I ran across, or in a few cases that I lived through. First, let's have a quiz. When was computing invented? And who was the first computer programmer? I'll give you a minute or two to think about that. When, you can guess a year, or if you want, even a decade. And then who was the first computer programmer? Okay, surprising answers. Computing was invented, I would claim, by Charles Babbage in 1822. And the first computer programmer was Ada King, the daughter of Lord Byron. Now, the idea of a mechanical calculator for mathematical functions really is a very old idea. It can be traced back to the 2nd century BC. Some early modern attempts have been attributed to famous mathematicians like Pascal and Leibniz during the 17th century. But those were all basically idea sharing. Charles Babbage began to specifically design a small thing that he called a difference engine around 1819. And by 1822, he had completed his design. He announced his invention in a paper to the Royal Astronomical Society. It was called Note on the Application of Machinery to the Computation of Astronomical and Mathematical Tables, unquote. Please note what he thought a computer was good for. His computer was powered by cranking a handle. The British government was interested, since producing tables was a time-consuming and expensive process for a government that thought a great deal of its navy and wanted to have very accurate maritime tables. In 1823, the British government gave Babbage a 1,700-pound initial funding to start work on his project. Although his design was feasible, frankly, the metalworking techniques of his era just couldn't make the parts in the precision and quantity required. So in 1832, Babbage and an associate named Joseph Clement produced a very small working prototype. It operated on 6-digit numbers and could make second-order differences. Now, Lady Byron described seeing this working prototype in 1833. Quote, We both went to see the thinking machine, or so it seems, last Monday. It raised several numbers to the second and third powers and extracted the root of a quadratic equation, unquote. But the British government wanted a full-scale machine, not just a prototype. It just proved to be too difficult, so work on the larger machine was suspended. Now, just like modern government projects, it had many delays and cost overruns. By the time the government finally abandoned the project in 1842, Babbage had received and spent over £17,000 on his development and still hadn't produced a working engine. Now, besides, Babbage had now become obsessed with designing an even more powerful machine that he called an analytical engine. He did complete his design, but he never built it. Now, Augusta Ada King, the Countess of Lovelace, was the daughter of the poet Lord Byron. She was also an English mathematician and writer. She was intrigued by Babbage's proposed analytical engine. She's thought by some to be the first person ever to recognize that the machine had applications beyond pure calculation of tables, and to have established the first algorithm that was intended to be carried out by his machine. As a result, she is normally regarded as the first computer programmer. Sadly, she died at age 36. Inspired by Babbage's difference engine in 1851, Per George Schutz built a large working machine that was demonstrated at the World's Fair in Paris in 1855. He sold it in 1856 to the Dudley Observatory in Albany, New York. It was the first printing calculator ever sold, and it weighed a mere 1,100 pounds. And another American, George Grant, started working on his calculating machine in 1869. He was completely unaware of the work of Babbage or Schutz. A year later, in 1870, he learned about difference engines and proceeded to design one for himself. In 1874, kind of a nerdy group called the Boston Thursday Club actually raised a subscription for the construction of a large-scale model, which Grant built in 1876. It weighed a mere 2,000 pounds. Now, all of these efforts were aimed at one goal: mechanical production of mathematical tables. 35 years after Grant's engine, the Burroughs Corporation in America built a machine for the Nautical Almanac Office of the US in 1912. Now, Burroughs eventually produced desktop mechanical adding machines that were very popular and were used in offices around the world well into the 1960s. During the 1980s, Alan Bromley at the University of Sydney studied Babbage's original drawings for his difference and analytical engines. They were in the Science Museum Library in London. This led the Science Museum to construct a working calculating section of Babbage's difference engine to celebrate the 200th anniversary of his birth. The conversion of the original design drawings into drawings suitable for manufacturing revealed some minor errors in Babbage's design. We think that those were introduced as a protection in case his plans were stolen. The engine and its printer worked flawlessly, and they still do. More important question is, when was the first electronic computer? Now, the University of Pennsylvania claims that Eniac was the first electronic computer. However, Iowa State College claimed that the Anatosoft Berry was the first. Frankly, nobody cared until 1947, and thereby hangs his tail. This is the Anatosoft Berry computer, or ABC. It was arguably the first automatic electronic digital computer. It was conceived in 1937 and built by Iowa State College mathematics and physics professor John Atanasoff, helped by a graduate student named Clifford Berry. Now, it was designed only to solve systems of linear equations, but that's a pretty important task, and it was successfully tested in 1942. In World War II, the US Defense Department wanted to improve their artillery. Building bigger, better guns wasn't enough. Each gun needed a firing table that told gunners how high to elevate the barrel to hit a target so many yards away. To be precise, the tables had to be very large. Each entry in the table required some sophisticated math that had to be done by human mathematicians. Producing the tables was a bottleneck. To fix it, the Department of Defense went to J. Presper Eckert and John Mauchly, two professors at the University of Pennsylvania, the men wearing suits in this picture. The government asked them to build a machine that could produce the tables for the new guns automatically. Once again, computers were being sought only as a tool to produce mathematical tables. Eckert and Mauchly designed and built the Electronic Numerical Integrator and Calculator, or Eniac. They built it in the basement of the Moore School. This picture of it was taken in 1945. Another quiz. How many computers are in this picture? Anybody want to unmute and take a guess?
One?
Yes, one.
That's a reasonable guess, but the correct answer is 3. Of course, all the machinery that you're seeing was in fact Eniac, and that we claim was a computer. But notice the 2 women in the room. The government wanted to be able to validate the work, the output from Eniac. And so they got 2 of the women that had been employed as full-time preparers of these firing tables by hand. Their official government job description was computer. So I would argue there are 3 computers in this picture. Okay, any questions so far?
Be sure to unmute yourself if you have a question.
Hello? You might mention that for a time there was a computer language named Ada, after Ada Lovelace.
Yes, we're going to get to that in a little while, but thank you for bringing that up. I promised a tale about Mr. Auckley and Professor Eckert, excuse me. In 1947, these 2 men were the first to file for a patent on a digital computing device. Now that was quite a surprise to Tanasinoff over at Iowa State. His ABC had been examined by John Mauchly in June of 41. And one of Tanasinoff's students, Isaac Auerbach, alleged that the design of the ABC influenced Mauchly's later work on Eniac, although Mauchly designed this. The Eniac patent was not issued until 17 years later, in 1964. By that time, Eniac had morphed into Univac and was sold by the Sperry Rand Corporation, a very profitable company. In 1967, Honeywell sued Sperry Rand in an attempt to break the Eniac patents. They argued that the Tanasinoff-Berry computer constituted prior art. The court released its judgment in 1973 and found that the Eniac patent was a derivative of the ABC. For almost 30 years, computers were designed, built, and sold on the assumption that the Eniac patent was not valid. If the court had ruled the other way, every company except Sperry Rand would have been liable for patent infringement, and the chaos might still be going on. Okay.
I thought you had mentioned ENIAC when you first introduced the ABC.
Yes, the ABC was produced and tested before ENIAC was. And John Mauchly, one of the 2 professors who created ENIAC, actually visited Iowa State and saw the ABC. And so it was at least one of Mauchly's colleagues claimed that Mauchly was influenced in his design of ENIAC by having looked at the ABC.
Thank you.
Okay, time for another quiz. What does IBM stand for? When was it founded? What did it originally manufacture and sell? And what is the most famous quote of its chief executive officer? I'll give you a minute to think about those. Okay, I think the first one's pretty straightforward. IBM stands for the International Business Machines, but the original name was CTR, Computing, Tabulating, and Recording Company. They changed the name to IBM in the 1920s. Now, when was it founded? Surprisingly, in the late 1800s. And what they first manufactured and sold was basically punch card machines. Their first large contract was providing equipment to tabulate the 1890 census. They sold punch card readers and tabulators. Now, the way that letters and numbers are encoded on punch cards is called Hollerith code, after the company founder, Herman Hollerith. And what's the most famous quote of its CEO? Well, that would be Thomas Watson in 1943, who said about electronic computers, "I think there's a world market for maybe 5 machines." Well, fast forward to the 60s. The IBM System 360 was a family of mainframes that made huge inroads into large companies and governments worldwide. Note that it was built and sold almost 10 years before the Eniac patent was finally invalidated. The cheapest version was the Model 30. It came equipped with up to 64 kilobytes of memory. That is 1/1,000,000th of the memory in my iPhone. Around 1960, IBM was looking for a large volume test site for this new family of computers. They picked an organization that was already a major customer for their punch card readers and tabulators, the Internal Revenue Service. The machines looked very promising, so IRS reorganized its tax return processing to use them. We built 7 large data processing centers, later expanded to 10, where tax returns could be given a few quick checks, and then the data would be encoded on IBM punch cards. The cards were then read on big card readers, who converted the data to magnetic tapes. And the tapes would then be shipped to a single site where a lot of IBM 360s would process the data and generate tax refunds or bills. The IRS's big IBM installation was in that hotbed of computer technology, Beckley, West Virginia. Why Beckley? Well, Senator Robert Byrd of West Virginia was chairman of the Senate Appropriations Committee for 18 years. Need I say more? For a while, I was a budget analyst for the IRS's Computer and Information Technology Division in the late 70s. I remember one year that IRS got its annual appropriation and was puzzled to find a line item providing several $1,000,000 for a strange sounding program in Beckley, West Virginia. We'd never heard of it, and we certainly didn't ask for it. When we inquired of the appropriations staff, they referred us to Senator Byrd, who told us, "I don't care what you do with the money, just so long as you spend it in West Virginia." So we did. 3 times, in the 70s, the 80s, and again in the 90s, IRS tried to modernize its tax processing system, but all efforts failed, either for lack of congressional support or our own management errors. When I retired from the IRS in 2000, the National Computing Center was still processing our tax return data in chunks of 80 characters. Why? Because that was how many columns are on an IBM punch card. But mainframe computers, filling entire rooms, were not the way of the future. Instead, very small computers would constitute the next chapter in the history of computing. The Apple I was the first effort by Steve Jobs and Steve Wozniak. Anybody want to pay $1.5 million for this one? That's a wooden case with a cutout for typewriter keys and a small TV monitor. This model still works. Less than 200 of them were sold. They were priced at $666.66 because Wozniak liked repeating decimals. To finance the first 50 units of production, Steve Jobs sold his VW microbus, and Wozniak sold his Hewlett-Packard calculator. The Apple I paved the way for the Apple II, which was a phenomenal success. It was introduced in 1977. Between September of 77 and September of 1980, annual sales rose from $775,000 to $118 million. Now, many companies saw potential in personal computers. There were lots of choices in the late 70s, but all of these computer hardware manufacturers went under. Very few survived. And personal computers, even the successful Apple II, were viewed by most companies as simply toys for adults. Then respectability happened. If IBM believed in PCs, they must be okay for businesses to use. The old maxim was still true. Nobody ever gets fired for buying IBM. Now, the Ibm Pc Operating System is an interesting story. IBM was the leading designer of big computers, and it had world-class software for running big computers. But that stuff wouldn't fit on a PC. The two men were sent to find an OS for the IBM PC, and they were engineers, not businessmen. They had identified two promising companies that wrote system software for small microprocessors. Both of them were on the West Coast. So they traveled first to Southern California to interview the head of a small company that had written an operating system, or an OS, for microcomputers. When they showed up at the appointed time, the office was empty. The surf was up, and that meant that almost all of the hippies and geeks who worked there had grabbed their surfboards and went out surfing. The IBM guys cooled their heels for a while, then gave up on that team and went to Seattle to interview another guy, Bill Gates. Neither Gates nor his buddy Paul Allen had written a successful OS. Now, they had written an interpreter for BASIC, which was a crude early programming language that ran on the Altair 8800 microcomputer. They'd also created a version of Unix for it. For the IBM guys, well, that was close enough. Gates knew how to write for these tiny computers. When they told Gates that they wanted to buy his microcomputer OS, Gates smiled and began negotiating terms. Soon, a contract was signed for $430,000. There was just one tiny problem. Gates didn't have an OS that would run on IBM's hardware. He had sold IBM a product that didn't exist. He just didn't bother to tell them. So he contacted Seattle Computer Products, a small company that had written a clone of CP/M. Now, CP/M, the control program for microcomputers, was at the time the most successful OS for the various PCs on the market. Gates bought their OS for $75,000 and began modifying it to become MS-DOS, the Microsoft Disk Operating System. He enabled it to read and write the latest hot product, 5¼ floppy disks. Now, undoubtedly, Bill Gates is brilliant, and he had the guts to sell IBM a product that he thought he could build, and he delivered it on time. He made a quick $300,000 profit, but that was not the best part of the story. IBM had a problem. They were a big, rich corporation, and they were constantly being sued by people who claimed that IBM had stolen their ideas. So IBM did not want to own the OS. Their contract specified that MS-DOS was to be Microsoft's property and explicitly allowed Microsoft to sell it to anybody else they wanted to. If somebody wanted to sue, they'd have to sue Microsoft. And what's the future in that, right? Well, the rest is history. IBM's PC made the personal computer a legitimate tool for businesses. And 96% of all IBM PCs ran MS-DOS. So Microsoft could pitch their OS to all the other PC manufacturers as exactly the same as IBM's. They raked in millions selling a product that IBM had paid them to develop. Any questions on that?
What became of the California surfer guys? Who were they?
I won't mention any names, but they were a rather famous small company that had produced a CP/M for other hardware. And they stayed in business for probably 5 or 6 years, but eventually CP/M lost out to MS-DOS, and then they went bankrupt. You would recognize the name if I told you. Needless to say, those folks are not proud of that story. Okay, no other questions? Let's go on. How many of you can remember screens that looked like this? This is how all PC screens looked in the early 80s. You typed in commands that had weird names and stuff would scroll onto the screen, if you spelled everything right. That seems pretty primitive to us now, but there wasn't any better way until 1984. When Apple introduced the Macintosh, it changed computing forever. It used a whole different screen called a graphical user interface, or GUI. But Apple didn't invent the GUI. Xerox Corporation had a West Coast think tank called the Palo Alto Research Center, or Xerox PARC. In the early 1970s, PARC researchers, Dr. Alan Kay, Dr. David Smith, and David Little, and some of their other staff came up with a better way for people to interact with computers, and thereby hangs a tale. Now, this may look like an early Apple computer, but it isn't. This was part of something called the Xerox Star. Xerox had been experimenting with a graphical user interface for several years, and they built a word processor called the Alto in 1972 for internal use. It was very well received by their employees, so in 1977, they began a project to make a commercial product using the graphical user interface, or GUI. In '81, they rolled this out, the Xerox Star. It was a wonderful computer, and it only cost $75,000. But you could add an additional workstation for only $16,000 more. In today's dollars, a single user system would have cost over $200,000. Understandably, there weren't very many sales. Several Apple engineers saw the Star when it was first presented at a computer conference, and they immediately realized the advantages. When the Star project ended in commercial failure, several of the PARC engineers left and joined Apple. Most notably, Dr. Alan Kay was lured with an Apple fellowship. Soon, Apple was a hotbed of cutting-edge ideas that had originated at Xerox. GUI, mouse and menu, object-oriented program, those were just the most famous ones. But Apple didn't just incorporate Xerox's ideas into their existing computer, the Apple II. GUIs required a much more powerful computer and very different hardware and software architectures. Apple's technical triumph wasn't introducing a GUI. It was building a hardware and an operating system that could run a GUI on a small PC that only cost $24.95, 1/30th of the Star's price. Well, they sold a ton of them, many of them to colleges and universities that wanted to expose their students to the future. As soon as Bill Gates saw a Mac, he knew that the scrolling screen of MS-DOS was doomed. He immediately ordered a crash project to duplicate this GUI in Microsoft OS. But this involved a total rebuilding of their operating system. Gates issued detailed orders about what the Microsoft GUI should do and how it should look. When the project's team leaders would complain that he was asking the impossible, Gates would invite them up to his office and show them his Macintosh. "This is how it's supposed to work," he would shout at them. MS-DOS was a big, complicated operating system. It was impossible to rewrite it for a GUI quickly. So the project team convinced Gates they could build a program that would run on top of MS-DOS that would look like a GUI. It was called Windows 1, released in late 1985. It was clunky and limited, and it didn't sell very well. When Windows 1 was released, Steve Jobs took out a full-page ad in the Wall Street Journal with this headline: "Now that we all agree on how a personal computer should work, why not buy one that really works that way?" Windows 2.0 came out in December of '87. It was much better and was better received. Version 2.03 for the first time allowed for overlapping windows on the screen. And that caused Apple to cry foul. They sued Microsoft for infringing on Apple's copyrights. Notice I said copyrights, not patents. The idea of patenting software was still controversial. They claimed, quite correctly, that Gates had copied the Mac interface as closely as possible. Well, of course he did. Gates was undeterred by the lawsuit. He introduced Windows 3.0 in 1990, 6 years after the original Mac. It was a real rewrite of the operating system and included some technical innovations that Microsoft had incorporated on their own, like virtual memory. Yeah, it crashed a lot, but it was a real GUI, and it came from the biggest PC operating system maker in the world. It sold very well. And 30 years later, the children and grandchildren of this operating system are still running on today's PCs, so long as they're not Apple or Unix. Remember that lawsuit? It was filed in '88. Apple lost in July of '89, but appealed. The case stayed alive until 1995, when the US Supreme Court denied Apple's petition for certiorari. Apple lost for 2 reasons. The first one was that its lawyers had foolishly granted a license to Microsoft to use key elements of the Mac interface in Windows 1.0. It was just a small moneymaker. But it was foolish because it was written in such a way that the license extended to Windows 1.0 and all future versions of Windows. But the second reason was the most interesting. Apple had hired several engineers away from Xerox and had lured Alan Kay away with an Apple fellowship. But they never gave anything to Xerox. Microsoft approached Xerox during the trial and offered them $1 million for the rights to their Xerox Star GUI. Xerox took the money and ran to the bank. And Microsoft claimed that if anyone was entitled to use the Xerox GUI, it was them, not Apple. So even though they had in fact copied the Mac slavishly, they won the lawsuit. Now, Apple was famously launched from Steve Jobs' father's garage in 1976. He and Steve Wozniak went from a 2-man startup to a successful large corporation in just 7 years. During the first 5 years, their revenues doubled every 4 months. In 1983, Steve Jobs was all in on the Macintosh project. He was personally involved in its design and development, but the company needed a traditional CEO to manage corporate affairs. So, Jobs recruited the president of Pepsi-Cola, John Sculley, to become Apple's CEO. His famous recruiting line was, "Do you want to sell sugar water for the rest of your life? Or come with me and change the world?" Sculley became the Apple CEO, and Jobs was then freed to become head of the Macintosh division. So technically, Jobs worked for Sculley. But hey, he was the founder, and he was Steve Jobs. The Mac was introduced in '84 to great fanfare and sold quite well initially. But by 1985, sales had slowed, and Jobs was dreaming of new, bigger, more expensive projects. The board of directors told Sculley to rein in Jobs, so Sculley tried to do so. But Steve tried to stage a coup to get rid of Sculley. Sculley found out about it, called an emergency board meeting, and the board backed him, stripping Jobs of all operational duties. Jobs had a temper tantrum and quit. Steve sold his fortune in Apple stock, stole a few key Apple employees, and founded a new company called Next Computer. He also, as a side project, bought a small computer animation company from George Lucas, Pixar. The goal of Next Computer was to start with a clean sheet of paper and design a new operating system based on Unix that incorporated all the cool new technologies and ran a GUI extremely well. Now that was a tall order, but Jobs had plenty of money and no deadlines. In 1988, Next released its first computer. In 1990, it released a second version. Just as important, the Next operating system was completely object-oriented. It was arguably the most modern operating system on the planet. They also created a powerful tool for making applications to run on Next. And they created one of the first corporate web page servers. Next was not a commercial success, but its technology was first class. And frankly, they had enough money to just keep on innovating. Meanwhile, back at Apple, innovation was not happening. The Mac was somewhat the same as it had been in 1984, although the hardware kept getting better. But the Mac operating system, its greatest strength when it was introduced in '84, was old and outdated by '96. They desperately needed to create a new modern operating system to compete with the Windows world. But several internal attempts resulted in failure. Many people thought that Apple was dead. Michael Dell famously said they should liquidate the company and give the money back to the shareholders. By 1997, Apple's market share was less than 3%, and the company was near collapse. They pinned their hopes on buying a new modern OS. When they looked around, the obvious best choice was the Next system. They swallowed their pride and bought Next for $439 million, plus 1.5 million shares of Apple stock, which frankly, the stock wasn't worth much at that time. Steve was brought back as a consultant, and when Steve arrived, Apple was just weeks away from bankruptcy. Now, you might think that the imminent death of Apple would have been good news for Microsoft, and it would have been, except for the Department of Justice. They had accused Microsoft of being a monopoly and proposed to break up the company. Gates desperately wanted to avoid that, so he argued that Apple was still a real competitor. And he did two things to shore up that argument. First, he invested $150 million of his personal fortune in Apple. And second, he announced that Microsoft Office, his cash cow and the premier product, would be ported to the Macintosh. These actions bought time for Microsoft's legal team and also for Apple's engineers. Jobs came back in February of '97. By July of that year, the board had fired the current CEO and made Jobs the interim CEO. In August, Jobs and Gates announced the Mac version of Office and Gates' investment. In November, Jobs announced a new way to buy Apple software, something called the Apple Store. In '97, he also found a British designer whose work really impressed him, Jonathan Ive. Jobs and Ive created a new vision for Apple products that would lead to a new vision for Apple Incorporated. By August 1998, the engineers had produced Ive's first design, the Imac. It was a startling break from the world of beige boxes with monitors on top and keyboards in front. The Mac was sexy again. It was a hit, and the money started flowing in. In 2001, Apple introduced the iPod. 1,000 songs in your pocket, Steve said. Apple didn't invent the portable music player. Sony had done that years before. But the iPod was slimmer, lighter, and had a unique, cool interface. Now, fortunately, the music industry thought the iPod was a trivial gadget. Steve asked the major record companies if he could sell digital copies of their music on a digital store so that young folks could listen to their favorite songs on his new device. The record companies saw no harm in that. They expected a small revenue stream, so they signed contracts. Steve even got permission to sell single tracks from albums for 99 cents, something that had never before been possible. Well, the rest is history. By the time the major labels woke up to the iPod's popularity, Apple was well on its way to becoming the largest vendor of music in the world. Apple had again turned an entire industry upside down. In 2007 came the biggest revolution. Apple reinvented the portable phone. Now, 5-pound bricks by Motorola had been around for years, and people who were very serious about mobile telephoning carried them around, sometimes in the trunks of their cars. The BlackBerry had produced the first compact, really portable phone, and it did email. That swept the business community. In fact, it was such an addictive product that many people called it the Crackberry. But Apple's design, again from Johnny Ive, was a complete rethinking of what a portable phone could be. There were just so many innovative features. A single button, no keyboard if you didn't need it, visual voicemail, a touch screen. But the birth of the iPhone was a strange one. In 2002, 5 years earlier, one of the software engineering groups had come up with a new concept for computer screens. A touch screen that you can scroll with your finger. And when you get to the end of the screen, it bounces off the end. When they showed it to Steve, he famously said, "Do you know what you've invented? This is the perfect interface for a portable device, like a phone." Johnny Ive got involved in a new project to see how this innovative user interface could be exploited. The ideas began blossoming all over the place. But every new feature or capability had to be personally approved by Steve. He demanded excellence in every detail. He could be almost abusive about it. His mantra was, "Apple doesn't make good products, only insanely great ones." Apple's recovery from near death is an amazing story, both technically and financially. Apple was near bankruptcy when Steve came back in '97. You could have bought 100 shares of Apple for $17. In 2001, when the Imac came out, a 2-for-1 split would have made your 200 shares worth $72, a real big return. There was another 2-for-1 split in 2005 and a 7-for-1 split in 2015. Today, your 2,800 shares of Apple would be worth over $374,000. And you'll have to forgive me for a moment. My phone rang and it turned off my notes. There we go. Last August, Apple became the first American company with a market cap over $2 trillion. Any questions?
Several times you mentioned object-oriented in reference to programming. Can you say a little bit about what that means?
Okay, thank you. Before object-oriented programming was developed, you wrote a computer program by just listing in one huge long list all the steps that the computer should take. Step 1, step 2, step 3, step 4. You might occasionally put in a what they would call a branching instruction that says, well, if register A is greater than 50, go to this address. If it's less than 50, go to this address. But aside from that, programs were just incredibly long lists of step-by-step instructions. Now, that worked reasonably well for simple programs, but once software started becoming more and more sophisticated, you developed programs that were hundreds of thousands of lines long. And that just became so unwieldy that the software became unreliable. Some folks came up with an idea for a different way of doing programming. They called it object-oriented because instead of writing a long list of instructions for the computer, you would create objects. These were software, but they were designed to represent things in the real world. And then you would give these objects various characteristics. And a program would run by simply letting one object send a message to another object saying, can you do this for me? And getting a response and so on. That kind of object-oriented approach, which was really almost like a conversation among different software objects, made it much easier to write programs that were modular, easier to test, easier to debug, and easier also to adapt to new purposes. So this object-oriented approach is now what virtually everybody uses, even those that are still using older languages like C. So object-oriented programming was a big deal. And Next was the first complete Unix-based operating system to be written in object-oriented code. Does that help a little bit?
Yes, absolutely. Thank you.
Okay. Any other questions?
Yeah, I have one. You mentioned very shortly the use of Unix, and I've heard of that before, and also Linux, and a lot of the operation of servers and so forth use Linux or Unix, and I don't know what those are. Well, Linux I know, but what is a Unix? Why
Okay.
is that something that's so popular for the software and servers?
That's a great question, Tom. And let me back up a little bit. When mainframes were still the big deal, something called time sharing was invented. We'll talk about it in a little while. And in order to enable time sharing, you needed to have a multi-processing mainframe. So they wrote an operating system called Multics, M-U-L-T-I-C-S, which allowed for multiple users to do time sharing. That was an open source operating system that was contributed to by a number of very bright people. And it became just like the standard way to operate a big mainframe. Well, somebody, I think at Bell Labs, thought that, that's such a great operating system. It's a shame that it's restricted to big mainframes. So they wrote a version of it that could be used for just a single computer with no time sharing. Since it was not a Multics, they called it a Unix for a single user system. That's where the name came from. The UNIX does not stand for anything. It was just like an inside joke. This was single user Multics. Well, Unix continued to be an open source system. And of course, open source software is notoriously safe, secure, and cheap. So Unix became the standard thing that people ran mid-sized computers on. Certainly the DEC computers all ran Unix. And it is still considered to be like the industrial strength background operating system. Now, it is not particularly user-friendly. If you've ever seen a pure Unix, well, you have seen pure Unix. On your IBM PC, you can go into what's called I think a program window or a background window. Anyway, you can go into a window that looks like the old MS-DOS, where you can give typed commands and answers. That is a Unix screen. Same thing's available on Mac. It's called the terminal. That's what Unix is like, and it is not user-friendly at all. So that's why Unix didn't really take off on personal computers. Somebody, long after the Mac came out, somebody decided that there ought to be a PC version of Unix that would be a little more user-friendly. And so it was done by a fellow by the name of Linus Torvalds. And so they named it Linux for, anyway, his first name combined with Unix. So Linux is simply the porting of Unix to PCs. Does that history help?
Oh man, that's incredible. I have often wondered where that or what that was, and um, I've played with Linux. I can't do much with it, but I did get it onto my machine once when XP failed and I had to erase the thing, and they quit, Microsoft quit using it. So I replaced it with a version of Linux and played with it. And, it's a whole different thing. It is also open source, right?
Well, Red Hat Linux, I know, is open source, and I think the other versions are also, which means that it keeps getting more and more powerful as various nerds make contributions to it. It is the only major operating system out there that is open source. And so for theoretical or for philosophical reasons, some people use it just because they think computing should be free.
Thank you.
Well, any other questions before we go on?
Actually, if Gary, if I could jump in and give a little backstory on Linux.
Yeah.
Some of our hearers might appreciate that the origin of Linux was from a guy named Andrew S. Tannenbaum, a noted author of computer science textbooks. And he wanted his students to be able to look at code for a real operating system. So he created something called Minix and published the source code with his textbook. And it was a real success as far as its limited ambitions went. And people kept saying, could you add this feature? Could you make it support this hardware? And his response was, well, I'm flattered, I guess, but really that's not what I want to do with it. But there's this other guy that you might want to talk to named Linus Torvalds. Linus had the same idea that, yes, I want to take this Minix thing into the real world. And so he and Tannenbaum pleasantly and amicably parted ways. Minix continues to be used in Tannenbaum's textbook. And Linux is, well, Linux. So you wonder if Tannenbaum ever had second thoughts about his career path. But every once in a while, those academics come up with something.
Is Linux or Unix better than the operating systems like Microsoft or Apple?
Well, I've got news for you. The Apple operating system, Mac OS, is based totally on Unix. That's why when you open up a Unix window on a Mac, it's called terminal, because it's simply a terminal into the Unix underneath. And ever since, Bruce, you probably know this better than I, a particular version of Windows, I think it was fairly late in the 90s or early 2000s that Windows went to a Unix-based operating system as well. So again, a lot of code on top of Unix to give it the nice GUI, but basically everybody is running on Unix these days. But both Mac and Windows users are accessing it through a very sophisticated GUI on top of Unix. Whereas Linux, I think, still uses much more primitive interface.
Question.
Is that right, Bruce?
Tom, to give you another angle on that question, I would say what you're asking is, what do you want to be compatible with? Because much of the software world and its evolution is based on compatibility. Getting the opportunity to do a project with lots of cash and a clean sheet of paper, like Steve Jobs had with Next, is a fairly rare thing. Because for some reason, these big companies don't want to throw away all the money they've ever spent on their computer systems. they want something that can interact with it. Even if it's not what the optimal solution would be, if it's good enough and interacts with what they already have, that's what they want. So your answer is almost always yes, Mr. Customer.
Question: how much are Minix and Linux worth? What's their value?
You mean financially?
Yes.
Well, again, correct me if I'm wrong, Bruce, but Linux itself is still free. However, you can get it from companies like Red Hat, who will then provide you with technical support. And what you're paying for is technical support, but the operating system is free. And I don't think that any of the contributors to Linux have ever made a dime directly.
I think you're right, and directly is absolutely the key word there.
Yeah.
Because people don't want devices, they want products. All right, they want something installed up and working for them. Even if, as Gary observes, the software is free, right? If somebody gives you a parcel of disks and said, well, here you go, you're probably not going to jump up and down with enthusiasm, because it's, oh, now I got to figure out what to do with this. How do I install it? Oh, something didn't go quite right. So much of the value of a computer system, not all of it by any means, but much of it is simply getting it to do what people want. And that is where companies like Red Hat make their money. What's the stock price or capitalization of Red Hat? I don't know. I'm sure it's more money than Andrew Tannenbaum has in the bank. But does that answer your question?
Yes.
If I'm not mistaken, Red Hat was bought by IBM.
That makes sense. Okay, well, I'll take this silence as an opportunity to move on.
Go for it.
I have another story about Steve Jobs. The roller coaster ride, that he had with his success initially at Apple and then being thrown out of his own company and then his comeback. It also had an effect on his personality and his character. When he and Wozniak were designing the Apple I in the garage, I mean, frankly, they were hippies. Steve had a live-in girlfriend, Chris Ann Brennan, who became pregnant in 1977, the same year that Jobs and Wozniak were introducing the Apple II. But amazingly, Steve did not take responsibility for the pregnancy. Chris Ann was devastated. She moved out and supported herself by cleaning houses for a while, finally ended up moving into an Oregon commune to have the baby. Lisa Brennan was born May 17th, 1978. Now, Steve was undoubtedly a genius, but he was also an arrogant, iconoclastic, insensitive, and some would say a jerk. He refused to acknowledge Lisa or pay any child support. Chris Ann was forced to file a paternity suit. A DNA test found that it was 94.1% certain that Jobs was the father, and he still claimed that he wasn't. The court ordered him to pay $385 a month in child support. Now, when Apple went public, Steve became a multimillionaire, so he voluntarily increased his child support to $500 a month. For years, he denied paternity. And yet, that big, expensive new project that Steve launched after the Macintosh, it was named the Lisa. 2 years after Steve was ousted from Apple, he finally acknowledged his now 9-year-old daughter, Lisa. He apologized to Chris Ann and tried to reconcile with Lisa. She wanted her surname changed, and Steve quickly arranged for a legal name change to Lisa Brennan Jobs. She eventually moved in with Steve and his wife, Laureen. Although he had grown up a lot, Steve was still a maverick at Apple and a difficult, often absent dad at home. When Lisa was admitted to Harvard, Steve initially refused to pay her tuition. At the office, he was more approachable than he had been in the early days, but everybody knew if your project was behind schedule or Steve didn't like your most recent progress report, you did not want to get into an elevator with him. His confrontations with first-line engineers were legendary. When he was diagnosed with cancer, Steve refused to follow medical advice for treatment. He believed some homeopathic method could cure him. By the time he was convinced that that wouldn't work, he was beyond hope. Steve stayed at the helm of Apple until almost the end. He took 2 medical leaves for liver transplants, but those didn't save him. But he always came back. On August 24th, 2011, he passed the torch to Tim Cook, and he died on October 5th. In his will, Steve made Lisa a multimillionaire. Apple's latest innovation had been the introduction of Siri, the voice control feature for iPhone. That technology had been developed by a spinoff from Stanford University called Stanford Research Institute, or SRI. They named their product Siri after their famous initials. But Apple fans around the world gave Siri a different meaning. They said it stood for Steve is right inside. Okay, time for another quiz, and I know at least one of you knows the answers. When the Pentagon decided to create a programming language for its own use, what did they name it and why? Where did the term computer come from? Where did the term computer bug come from? Where did Google's name come from? And I'm a nerd, but who coined that term? I'll give you a minute to think about your answers. Okay, anybody want to repeat what was the reason, what was the name of the Pentagon's programming language?
Ada?
It was Ada, named after Lady Lovelace. And the term computer, if you were listening earlier, that originally meant the humans, mostly women, who computed those mathematical tables for the Pentagon's big cannons. And eventually the name was simply given to the electronic machines that replaced the women. Where did the term computer bug come from? Well, there's some dispute about that. One of the Pentagon's famous admirals, Amazing Grace Hopper, had an insect taped to one of the pages in her journal. And some have said that's the origin of the term. But those of us who graduated from Penn believe the other story. As I mentioned, Eniac was built in the basement of the Moore School, which was completely underground. And in the wintertime, it was cold and dank. Well, when Eniac was running, it was full of vacuum tubes that created a tremendous amount of heat. And all the bugs that were in that basement were drawn to the Eniac room where they could nestle up against a nice warm vacuum tube. Every once in a while, one of them would nestle a little too close and get himself fried, and in the process, destroy the vacuum tube. Well, the engineers that maintained that system were all on 24-hour call. So if a bug got himself killed in the middle of the night, the operators would call up an engineer at home and say, hey, come on down here and fix this. It became such a regular event that the engineers developed some algorithms. If the operators would call and say, it's not working, the engineer would ask, what wasn't working? Which register was giving the wrong answer? When they got that, they would then say, okay, tell me what the wrong answer is like. And they would then have a pretty good idea. They'd say, open up drawer number 3 and look in row 6 for a vacuum tube that isn't lit. If you find it, replace it, and by the way, remove the bug that's going to be dead underneath it. I believe that it was in fact the origin of the term computer bug, and it was later extended to software. Okay, Google's name is really a play on the word Google. It means the number 1 followed by 100 zeros. Sergey Brin and Larry Page joked that this was how much information they could produce with their algorithm. And by the way, once they became a rich corporation, they built a very fancy headquarters and they named it the Googleplex. A Googleplex is a 1 followed by 1 Google zeros. Okay, who coined the term nerd? Dr. Seuss. Okay, the internet is one of the most amazing technological advances of the 20th century. Nearly 2/3 of the world's people are connected to it. Every minute, the internet handles an enormous amount of traffic. But how did it happen? Why is it designed the way that it is? Well, like so many technologies, the internet grew out of earlier ideas and techniques that no one had anticipated would someday connect the whole planet. In the 1950s, all computers were mainframes that lived in huge rooms with sizable staffs to service them. Keyboards and card readers were used to input commands and data, and printers gave the output. As cathode ray tubes, or CRTs, were introduced, output could be directed to either a printer or to a screen. A keyboard and a CRT together were called a terminal. They were used to interact with the computer, and at first, the terminals were all inside the computer room. But eventually, terminals were placed in more convenient locations for the humans and connected by cables to the computer room. These remote terminals made it possible for the mainframe to be considered an invisible, distant resource. Mainframes were huge, delicate, and expensive, but terminals were cheap, simple, and would fit on a desk. So terminals proliferated in companies and universities. An operating system called Multics, there you go, Tom, was developed that allowed multiple users to share a mainframe. Now, this time-sharing scheme let many users simultaneously behave as though they had total control of a powerful computer. This made terminals even more desirable and more valuable. Large research universities had many computer users densely packed in a campus. They had telephone lines directly connecting campus buildings, so it made sense to develop ways to transmit data over phone lines. Then everyone on campus could use the school's mainframes. Many schools invented methods or protocols to make these campus networks work efficiently. There was some sharing of ideas and there were best practices, but the leading universities all had their own unique and proprietary campus networks. Almost all research universities did government-sponsored research. In the field of computer science, most of that was sponsored by a Pentagon group that viewed computer science as a strategic technology. It was called ARPA, the Advanced Research Projects Agency. They would sponsor conferences several times a year at which their sponsored university researchers would share ideas and information. But conferences are expensive. Letting researchers interact daily instead of a couple times a year would speed up progress and promote collaboration. So ARPA issued a contract in 1969 for creating connections between the various campus networks. It was called, logically, ARPANET. It was not intended to create a single network protocol that all the schools would have to adopt. Instead, it was to be a network of networks, or an inter-network communications capability. That's the origin of the term internet. But the ARPANET was a far cry from today's net. How did it morph into the connecting tissue of the world's minds? Why does it work the way it does? Well, thereby hangs a tale. ARPA asked a Boston consulting firm, Bolt, Beranek, and Newman, to build their initial network. Their first link was between UCLA and the Stanford Research Institute. These were both big ARPA research centers. And besides, trips to Southern California during Boston's winter seemed like a really good idea. On October 29th, 1969, they ran their first test of the connection. Leonard Kleinrock of UCLA called his counterpart at Stanford on the phone and said he was about to transmit the word login. The conversation went like this. He says, "We type the L and we ask on the phone, 'Do you see the L?' 'Yes, we see an L,' came the response. We type the O and we ask, 'Do you see the O?' 'Yeah, we see the O.' They were getting so excited. Then we typed the G and the whole system crashed. That's how research often goes. But within a few months, they had a working connection among 4 ARPA schools: UCLA, Stanford Research Institute, UC Santa Barbara, and the University of Utah. With the basic connection problem solved, ARPA quickly leased a bunch of long-distance phone lines from AT&T, and within a year, they had 18 research labs all connected to each other. But more importantly, professors and grad students at these institutions began to experiment with the new tool. An addressing scheme was developed that allowed you to access any particular computer at any particular school, or even to address a particular user at a school and send them text that would appear on their screen instantly. We call it email today, but a better description at first would have been nerd chat. ARPANET was not the only attempt to connect universities. It was just the model that the world eventually adopted. One of the other attempts deserves honorable mention: Merit. In 1966, 3 years before ARPA's famous contract, 3 leading universities, all in Michigan, formed the Michigan Educational Research Information Triad, or Merit. They developed their own system with very little financial assistance. In 1972, they successfully linked the 3 schools. By 76, they had developed protocols that allowed dial-in access to Merit from anywhere in the United States. This was a big deal. In 78, a 4th school was added, our own Western Michigan University. But by the 80s, it was clear that ARPANET was the major academic network. So Merit modified their protocols to accommodate ARPA's TCP/IP standard. This allowed the Michigan schools to join the ARPANET. This was a heartwarming example of cooperation among Michigan's premier academic institutions. But, you know, relations were not always quite so smooth. Now, I'll admit this has nothing to do with computer science, but I think it's an interesting story. When many people think of the University of Michigan, they think of college football and the school's famous medical center. That other school down the road, the one they called the Cow College, wanted to best their rival in both areas. In football, Michigan State did pretty well, but all their proposals to add a school of medicine were shot down in the Michigan legislature, largely due to U of M's fierce resistance. 2 of the biggest dates on Michigan's football schedule are the Michigan State and the Ohio State games. Originally, both of them would be home games in one year and away games the next. This produced lopsided revenues for the school and for the city of Ann Arbor. Michigan wanted to smooth that out, but Ohio State refused to budge. So MSU offered a bargain. Support our proposal for a medical school and we'll switch home games. All of a sudden, MSU got a medical school and Michigan got smoothed out revenue streams. Okay, back to computer history. As I said, lots of researchers experimented with this new ARPANET. Many of their projects were funded by ARPA, later named DARPA, via research grants. Now, a grant was always to a professor, the principal investigator. That person could decide how to carry out the project. She could decide to spend the money on professor salaries, very expensive, or grad student stipends that were dirt cheap. Professors live in the world of publish or perish. If a grant will lead to scholarly papers that will be accepted at prestigious conferences or in journals, then the principal investigator will take a personal interest and take the credit. But if the work looks merely practical, not requiring any new theories or ideas, the principal investigator will tend to assign it to grad students with only loose supervision. Developing standards and protocols for data communication didn't look like a path to fame or to tenure. So the majority of all the protocols developed for ARPANET were done by groups of grad students. As many of you know, grad students lived low-budget lives. In those early days, they dreamed of academic jobs, not business employment. They got respect in their schools by cooperating and contributing. And the network they were working with consisted of schools that were peers. There was no hierarchy on the ARPANET. There was no central control or even a system operator. So it was only logical that these students developed protocols that were cooperative, non-commercial, and with distributed management. ARPANET became a peer network. Trust me, if IBM or Sperry Rand had been given the contract to develop internet protocols, the questions of who's paying for this and how much money can we make would have been considered early and often. In fact, for a while, commercial entities were not allowed to join ARPANET. It was only later that profit-seeking companies were allowed to join. In 1983, the Pentagon created a separate network, MILNET, for secure communications among defense agencies. 2 years later, it became clear that corporations should be added. To avoid lumping all kinds of network nodes together, they came up with a system of top-level domains. One of them, called .com, was created for commercial enterprises, .edu for educational institutions, and so on. This domain name system could be expanded as needed to provide for more specialization, and it has been. You'll recall that the original goal of ARPANET was to let researchers share ideas and papers. Scholarly papers, of course, must have extensive footnotes citing prior work and related research. For centuries, when a scholar read a paper, he would go to the university's library and look up the papers cited in the footnotes. This was slow and tedious, but there was no other way to do it until 1990. Tim Berners-Lee was a computer scientist at CERN, the European atom smasher. He developed Hypertext, a way to embed the address of a file in a digital document. This allowed the footnotes of a scholarly paper to contain the traditional citation, but allowed the reader to click on it and be taken to a file containing the cited paper. Since the paper might be on a computer anywhere in the world, he needed a universal system for describing how to reach the file containing the paper. So he developed the URL, the Universal Resource Locator. And of course, sending hypertext documents over the internet required its own special protocols. So the HTTP standard was developed, Hypertext Transfer Protocol. Berners-Lee envisioned papers that pointed to other papers that pointed to still more papers, creating a spider web of links. And the papers could be anywhere in the world via URLs. So he said it would be a worldwide web of citations. Creating a hypertext document would require a standard method, a language for describing the way a document should look and how the links should work. Well, the publishing industry had created the Standard Generalized Markup Language, or SGML, as a way to describe how a page should look in a book or a magazine. So Berners-Lee adapted that idea to his purpose, creating the Hypertext Markup Language, or HTML. HTML has been enriched several times, but every web page you look at today was created with HTML. The original tools for viewing hypertext documents were fairly crude, but the folks at the National Center for Supercomputing Applications at the University of Illinois came up with a much better way, a graphical hypertext display program. They called it a browser, and they called theirs Mosaic. Mosaic was made available for free for non-commercial users. The code for the Unix version was published, and the code for all the other versions, including Windows, was shared freely under a licensing agreement. A group of students who had worked on Mosaic at Illinois formed a spin-off company called Mosaic Communications Corporation. The name was later changed to Netscape Communications. They did not copy any code from Mosaic, but copied and improved all of its ideas in a browser that they called the Netscape Navigator. Thus began the browser wars with Microsoft. But that's a story of its own. I'm going to stop here and entertain any more questions.
Your last comments brought in something that I was going to ask a question about. Where was the rest of the world during our creation of computers?
That's a good question, and I'm afraid that I would give an America-centric answer. If somebody knows better, please holler. But quite frankly, not many other countries invested in the kind of research that DARPA was willing to fund. So even though companies were formed in other countries to build, for instance, mainframes and personal computers, they all basically just took American designs and manufactured them with cheap labor. The term Asian knockoff was applied early to any computers that were made by companies other than Americans. And it's still true. Well, okay, it was true until about maybe 5 or 10 years ago, that almost all of the breakthroughs in computer science are coming either from American universities or other universities in partnership with ours. This is an area that, of course, China is now challenging very strongly, and they're challenging it particularly in the area of artificial intelligence. Japan launched an earlier challenge in the area of supercomputing, and they built a number of Japanese supercomputers that were, frankly, very good competitors with the American supercomputer companies, and notably Cray. Does that partially answer your question?
Partially, but it's hard to believe that the rest of the world where there's lots of brains, I mean, my God, we all came from other places, that they weren't developing computers as early as we were.
Well, that's a reasonable assumption, but the best history that I can find says that indeed, all of this early research that led to computing was led primarily by American corporations and American universities. And again, you know, DARPA gets a lot of the credit because they spent a ton of money. When I was a grad student in the 80s, I was on a study fellowship from the federal government, so I visited a number of major research universities. And it was almost a joke. Any computer room you went into at a major university had little plaques on the back with a DARPA property number. The government had paid for all their hardware. Other countries were not doing that.
Is there
Gary,
any international licensing that prohibits transfer of some ideas and so forth that can be enforced?
Well, any technology that's considered to be significant for military reasons does have restrictions on it. But to my knowledge, those restrictions were not placed, certainly on personal computers, not even on mid-sized mini computers.
Gary, you're right. I spent a lot of time studying computer history because I got involved early in the 60s. One of the things I do know about is in Russia, in the late 60s and early 70s, they had it was called the RAD, R-A-D, not like the slang term today, but there was the RAD series of computers that were all 360 knockoffs.
Mhm.
And because when I was a CIO, I had a couple of people that worked in my department who had immigrated, and they worked on those machines. And so I know that was one line, but again, they were just copycats.
Yeah, I mean, manufacturing of computer hardware did indeed spread around the world, but all the designs, as I say, until about 5 or 10 years ago, all of them were American. When I was getting my PhD at Penn, Penn is a very old traditional university, and in all their doctoral programs except one, there's still a foreign language requirement. However, in computer science, they've waived that. The excuse was because you have to learn computer languages, so that should count. But the real reason was because even computer conferences hosted in other countries, the papers are delivered in English because America dominated computer science for so long.
Well, Germany has such a history in mathematics too. Where were they?
Well, I'm sure that Germany made a number of contributions in theory. And certainly, you know, the names of the American researchers ran the gamut of other nationalities. I'm not saying that these were all, you know, WASPs who were doing the research. In fact, if it wasn't for Asian researchers at American universities, we wouldn't be where we are. But nonetheless, in terms of national contributions, until 5 or 10 years ago, I mean, it was the United States, period.
Yeah, another one, another famous computer, well, he was a mathematician, was John von Neumann.
Mm-hmm.
And he was German, but he was also involved in the Manhattan Project. But he came up with the whole idea of the architecture of the early computer architecture that that he espoused, that the software and the data should all reside in memory at once. The Eniac and the other early machines, the software and the programs and the data were separate in separate parts of the system. And he pioneered that concept. And so all the computers going forward have always been referred to as the John von Neumann design.
Yes, that's correct. But you'll recall, where did he end up?
Well, he worked on the Manhattan Project, but yeah, government. In fact, there's a very famous story. There's a great history book about him that when he was on his deathbed, there were some military generals, whatever, who were there to, in case he said anything in his dying hours and minutes, they wanted to make sure that it was secure and captured.
Yeah. Yeah, I know that during the 60s, it was considered to be almost unthinkable to be in favor of the government, especially the Defense Department. But most of the technology that those children of the 60s were using was paid for originally by DARPA.
Gary, does the phrase core memory ring a bell?
Yes, and are you going to remind us where that term came from?
Well, I found this in my basement. I don't know how well it shows up, but each of the little black spots is a tiny ferrite donut. And there are 3 wires running through each little donut, 2 of them perpendicular and another one diagonally. And this, I believe, is what was called a core plane. And I found it in a surplus electronics store in Chicago a long, long time ago. I used to kind of hold this up and wave it around when I was teaching a little bit of computer history at the Illinois Institute of Technology.
Yeah, core memory.
Magnetic core. That was where everything had to be loaded to run the program, as distinct from the tape or disk storage.
And given the size of that little exhibit, you can understand why 64,000 kilobytes, or 64 kilobytes or 64,000 bytes of memory took up a lot of space. That was considered to be big. and yet it's puny by modern standards.
Each of those little ferrite donuts represented 1 bit.
Yeah. Which is why computer programmers from early days were all called bit bangers. Well, I'm enjoying this conversation, but we should ask if there are any other questions. If not, we need to respect time.
How did
Excellent
programming
job,
come
Gary.
about where it is now?
I didn't hear all of that question.
Programming, it used to be done, you know, by people. How does it function now?
Well, programming in one sense is still done by people. However, when I first started programming in the early 70s, you wrote out instructions line by line telling the computer what to do. And you were writing in English language, sort of, but it looked a lot like the way that the instructions would actually be entered into the computer. Nowadays, if you write a computer program, you use a higher level language where you can, you can write 1 or 2 lines in fairly understandable English, and then a computer program called a compiler will compile that into many dozens, sometimes hundreds of lines of code that the computer can read. So in one sense, the programs that the computers read these days are all written by other computers, but ultimately there's a human at the top of the stack who's deciding what should be done.
Thank you.
And that, of course, ignores the whole issue of deep learning, which is outside the scope of today's conversation.
I have a personal question. You talked about your phone rang and it took your screen off. Well, that same thing happened to me as I was trying to listen to your reply about the question of what happened with the guys that didn't get the job of the government in Southern California.
The folks that IBM went to visit, but they all went surfing.
Right. What
Yeah,
happened to that? Because I missed that because my phone call came in right when you were going to give that answer.
Well, I said I wasn't going to name any names, but it was a company that had written CPM, the control program for microcomputers, for a particular piece of hardware. And they stuck around for a little while, but eventually they went bankrupt.
Okay, thank you.
Well, we are a little bit over time, so I'll go ahead and wrap the class. Gary, thank you so much for just an incredibly compelling conversation. A lot of things that many of us don't know, and sounds like we have some people on here that not only know this information, but probably helped develop some of the technologies that we are enjoying today. So thank you for all of your contributions, but thanks for a great talk. And if anybody else has something to say it now. Otherwise, I will close the class.
Excellent job,
Yay.
Gary.
Thank you, Gary.
Thank you.
Thanks a lot.
Fabulous
Thank you,
talk.
Gary.
It
Good
was
job.
fun.
Very good.